Good morning. Welcome back to Microeconomic Theory II. Good morning, everybody. Welcome back to Microeconomic Theory II. Today, we will learn about simultaneous game. In the simultaneous game, we call the components of the game. First, we have players. In this game, we have more than one player as usual. 2. Rule. The rule of the game. All players move at the same time. This is very specific to the simultaneous game. 3. Strategy or choices for action. In this simultaneous game, players have strategy or choices for their actions. And 4. Payoffs for all players. In the end, all players will realize their payoffs. Looking at the payoffs matrix for the simultaneous game, you see we have player A on the left hand side and player B on the top of the table. And then we have two strategies. First, go to university, and second, go to the airport. You are familiar with these payoffs because this is the example in last lecture. So you see the payoffs in the matrix. If both player A and player B go to university, they are both happy. A happy and B happy. But if they miss to meet each other, then you see that A will not happy and B will not happy too. Now, we turn the happiness into some numbers. You see that happiness is for 100. The unit of happiness is utils. Economists generate the units of happiness or the utilities. Then the unit of the utility is utils. Therefore, if A go to university and B go to university too, A and B will gain 100 utils. But if player A misses to meet player B at the airport or university, then player A is unhappy and player A lose 100 utils or minus 100. Then player B also loses 100 utils as well. Therefore, the payoffs of A and B is minus 100 and minus 100 in that case. Here you see that we have 4 cases of the results. Now, we turn to how to solve simultaneous game. We solve the simultaneous game by reaction function. I will introduce you to the reaction function. Here, first, we find the reaction function of player A. So, we recall the payoffs matrix of player A and player B for the game of meeting each other at the university or the airport. Here, the reaction function begins with if player B do something. For example, in this case, if player B go to university, what would player A do? So you see that the first item or the first number in the bracket is the payoff of player A. Then you compare 100 and minus 100. If player A go to university too, they are both happy and player A will get 100 utils. But if player A go to the airport, they miss to meet each other and then player A will get minus 100 utils. So what is better between 100 and minus 100. You see that 100 is better. Therefore, if player B go to university, then player A will go to university too. This is the relation function of player A. Now, we turn to if player B go to the airport, and then you see that player A have to compare with the payoffs of minus 100 if he or she goes to university, and positive of 100. So you see that this is the better choice because 100 is much more than minus 100. Therefore, player A will choose to go to the airport. Therefore, the relation function in this case, if player B go to the airport, then player A goes to the airport too. Here we write the relation function of player A like this. We have two relation functions. Relation 1, if B goes to the university, and then A will go to university too. And the relation function number 2, if B goes to the airport, then A will go to the airport too. Here we find the relation function of player B. We use the same method, if and then. First, if player A goes to university, then B compare with 100 and minus 100. You see that B will gain 100 if B goes to university too, but will lose 100 U-tunes if he or she goes to the airport. Therefore, which is better? Yes, going to the university is better because 100 is more than minus 100. Therefore, if player A goes to university, then player B will go to university too. This is the relation function of player B. Here we are. If player A goes to the airport, then B has to compare between minus 100 and plus 100. Therefore, player B will go to the airport too because 100 is more than minus 100. That's correct. Therefore, the relation functions of player B. We have two cases of the relation functions. First, if A goes to university, then B goes to university too. And if A goes to airport, then B goes to the airport. These are relation functions of player B. Now, you know about the relation function, so let's apply it in these following games. Game number 1. Game with one equilibrium. Suppose we are playing the investment game between player A and player B. So you see the strategy here. Both players can build big factory or small factory. Therefore, the choices of player A is big factory and small factory. Player A has to choose between big factory or small factory. And in the same situation, player B will have to choose a big factory or small factory too. They choose at the same time, so it is the simultaneous game. Simultaneous game is player A and player B move at the same time. Now, we look at the payoff in the matrix. You see that if player A built a big factory and player B built a big factory too, they will have just only 100 and 100 million baht for the profit. Why? Because the supplying is very much. Here, if the greater supplying is supplied into the market, then the price drops and the profit of player A and player B will be lowered. So, what if player A and player B build small factories? You see that both A and B will gain 250 million baht. So, the situation is better. Here you see 4 small factories, then the numbers of supplying which will be sold into the market will be small. Therefore, the price will be high. And the profit of player A and player B will be high as well. Therefore, if we look at this game, player A and player B, must choose small factories. But what would happen in the game, we will see next. But let us look at another choice. So small factory and big factory. So what would happen? You see that the supplying is not so many or not so little. Therefore, the price is not so high and the price is not so low. So the price is in the middle. And both of them will gain something. But the big factory will gain more because of the numbers of supplying, which is greater. So the price is good, and player with big factory have many more products to sell. Therefore, they gain more. So in this case, you see that if player A has a big factory and player B has a small factory, then A will gain 350, while player B will gain just only 50. But in another case, if player A has a small factory and player B has a big factory, then player A will get just only 50 and player B will get 350 in the unit of million baht. These are something that will change the game. So, to solve the game, especially the simultaneous game, you have to find the relation functions. Now we find the relation functions of player A. So we begin at if player B do something, then what would player A do? So if B builds a big factory, then A has to compare between 150. So you see that the payoffs on the left hand side and in the bracket is belongs to player A. So here 150, which one is better? You're right, 100 is better. Therefore, if player B builds a big factory, then player A has to build a big factory too. Another relation function, if player B builds a small factory, then player A has to compare between 350 and 250. Which one is better? So it is obvious that 350 is better than 250. Therefore, player A builds big factory. You see that the relation function of player A. Now, the first relation function, if B builds a big factory, then A builds a big factory too. And the second relation function, if B builds a small factory, then A will still build a big factory. We call it the dominant strategy of player A. No matter what B chooses, A will choose the same strategy. In this case, big factory is the dominant strategy of A. You recall that no matter if B builds a big factory or a small factory, then A will still build a big factory. So no matter what B chooses, whether it is the big or small factory, A will choose the same strategy, which is the big factory, always. So the big factory is the dominant strategy of A. Now we turn to the payoff matrix again. So we find the relation functions of player B. We begin with if player A do something, then player B reacts to do something. Here, if player A builds a big factory, then player B will compare between 150. The payoff on the right hand side in the bracket is belonged to player B. Therefore, player B has to compare between 150. Which one is better? 100 is better, of course. Therefore, if player A chooses to build a big factory, then player B will choose to build a big factory too. another relation function. If player A builds a small factory, you have to compare between 350 and 250 for player B. Which one is better? You see that 350 is better. You are right. Then if player A builds a small factory, then player B builds a big factory. Here is very crucial for the answers of the game. You see that player B has the dominant strategy too. It is, no matter what A chooses, B will choose the same strategy. In this case, B has to choose big factory, and big factory is the dominant strategy of B. No matter A chooses big or small factories, B will choose always the big factory. So big factory is the dominant strategy of B. Very good. Now we find the equilibrium of the game. It is obvious when A always chooses big factory and B always chooses big factory too. So both players end up to build big factory. Therefore, big factory and big factory will be the equilibrium of the game. So it is the answer of the game. The equilibrium of the game means the answer of the game. So the game ends up at A builds big factory and B builds big factory. And the payoffs, or the gains that both player A and player B will get in this game. They both gain the payoffs 100 and 100 million baht. So player A gains 100 and player B gains 100. You may think of a better payoffs 250 and 250 if both build the small factories. But it is not the equilibrium of the game now. Why? Because A has the dominant strategy to build a big factory, and B has also the dominant strategy to build a big factory. So we will discuss later how to gain the highest payoffs. But now you can see that the equilibrium of the game doesn't allow both players to have the highest payoff, which is 250 and 250, but they gain just only 100 and 100. Very surprising, very strange, but it is real. Now, I will introduce you to the Nash equilibrium. The game has Nash equilibrium when the equilibrium comes from the matching between reaction functions of all players. The matching of reaction functions, what it is. So you see the reaction functions again here. The reaction function of A states that if B builds a big factory, then A builds a big factory. And reaction of B says that if A builds a big factory, then B builds a big factory. So you see the relationship between those reaction functions here. If you think about A, if A builds a big factory, then B builds a big factory, and if B builds a big factory, then A builds a big factory. Therefore, for the reaction function of A, if B builds a big factory, then A builds a big factory, and if A builds a big factory in reaction function of B, then B will build a big factory. So you see the linkages between the reaction function of A and reaction function of B. And now you see another linkage. Here, if A builds a big factory, then B builds a big factory. And you can repeat, if B builds a big factory, then A builds a big factory. You can repeat this again and again and again and again. Therefore, you can read it through and smooth. If B builds a big factory, then A builds a big factory. And if A builds a big factory, then B builds a big factory. So it can be repeated. In this payoff matrix, you see that if player B chooses to build a big factory, then player A will choose to build big factory. And if player A chooses to build a big factory, and then player B will choose to build big factory. So if B big factory, then A big factory. If A big factory, then B big factory. So you can find this matching of relation functions. You can say it smoothly. So it is the circular flow of the relation functions here. If B big factory, then A big factory. If A big factory, then B big factory. And you can repeat this forever. So the point that you can repeat these relation functions forever and smoothly with the circular flow of these relation functions, then that is the Nash equilibrium. You may notice that if A and B has dominant strategy, it means that both player A and player B have the dominant strategy, which is big factory. Then the Nash equilibrium will be just only one point in this payoff matrix, which is big factory and big factory. Other points will not be the Nash equilibrium. This is why the choice of small factory and small factory, which may yield higher payoffs, will not be chosen because it is not the equilibrium of the game. It is better in terms of payoffs, but it is not chosen by player A and player B. Therefore, it is not possible for this choice to happen. Something that is better, but impossible to happen. It's not a thing that we can have in our life. Therefore, it may be a dream or it may be ideal to have that point, but in reality, we cannot have that point. The reality is that we have a big factory and big factory because this is the highest rational choice. So it is possible to happen because it is not just because of you. It's because of another player, your opponents, or your teammates, or your friends. It depends on others. So game theory teaches you that it is not just because of you in the determination of the payoffs or the results of the game. It depends on another side which will determine the results of the game. Here you see that if you try to build a big factory and you expect that you may gain 350 if another player just builds a small factory. This is just the expectation, but it is not true in reality because other players have to think too. And the most rational choice for him or for her is also the big factory. And you end up with just only 100 for your payoffs because another player chooses to build a big factory too. This is game theory. The game that yields the payoffs depending on the action of another players. You see that it is not just because of you, but because of all the players in the game that determine the result of the game. Very good. What we have learned in this class today: first, we solved the simultaneous game by the relation functions. Second, we learned about the dominant strategy. And third, we learned about the Nash equilibrium. You see that we have much more to learn about the game theory and many interesting things. It is all for the class today, so I would like you to repeat the simultaneous game and the relation functions and trying to understand about the dominant strategy and Nash equilibrium again. So see you next class. 再见. สวัสดีครับ